Okay, so let's start off by talking about this chart here. This chart should look very familiar. If you're going from mass to mole, or mole to mass, you divide or multiply by the molar mass. If you're going from volume to mole or mole to volume, you divide or multiply by 22.4. From mole to particle or particle to mole, you use 6.022 e to the 23rd. And based on the direction you're going to divide if you're going up, multiply if you're going down. Now it's the same process with this chart, just a little bit more complicated slightly, but not really. The only new step in here is this yellow part here. It's your mole to mole ratio. Everything else in between is exactly the same. This is all the same. Okay, so this will make more sense once we get started. Let's look at a sample problem. Determine the percent yield for the reaction between 46.1 grams of cesium and 13.4 grams of oxygen if 28.3 grams of cesium oxide is produced. Okay, so let's see here. Where's my pencil? Here we go. So the first step you want to take is you want to write out your equation. Okay, so let's go ahead and write out what we know. Cesium, so Cs, and oxygen, O2. They produce, it says here, CS2O. Okay, that's good. Now let's take the information that we're also provided with. We're also provided with 46.1 under cesium, so 46.1 grams. And 13.4 grams of oxygen, 13.4 grams. And this is produced 28.3 grams. There's a problem with our equation here. It's not balanced. We have to have a balanced equation due to the law of conservation of mass. It states that matter cannot be created nor destroyed. Therefore, we need to go ahead and balance this. So same thing on the left, same thing on the right. So let's do oxygen first. 1 oxygen, 2 oxygen. So let's put a 2 on this side. So 2 oxygen, 2 oxygen. 2 times 2 is 4. Okay, so we need 4 cesium here. Perfect. Now we're balanced. Now we can start the math. Okay. So, where are we? Let's get this out. So we're starting at 46.1 grams, and we want to go to unknown. We want to find the excess, and we want to find the limiting reactant. We don't know that. In order to find percent yield, we must find the limiting reactant, because that needs to be the product needs to be divided by the limiting reactant, basically. But let's not get confused here. So let's just take 46.1. I'm eventually going to have to do both cesium and oxygen. I'm just choosing to do cesium first. Order does not really matter. So we get our periodic table out. We need to see what is the molar mass of cesium, and it is 132.9. Okay, 132.9. 132.9. Okay, good. How did I know how to do that? Because I'm going from mass in grams to mole, given. So you're going up, you're going to divide. So 46.1 going up to mole, so we divided by the molar mass of cesium. Now we're at the mole to mole part. We need to go to the unknown part. Okay, so we need to, this will be 1 mole. We need to go, okay, given goes on bottom, given goes on bottom, given always goes on the bottom. So cesium is a given, so that'll be 4, and we're going to the 2, we're going to the CS2O, good. So now we just went from mole to mole, and now we want to go from mole to mass, because we started a mass on the other side. So we're going to now multiply by the unknown, which is cesium CS2O. So if I get my periodic table back out, we need to use the molar mass, multiply. It'll go in this spot right here. So CS2O, So cesium is right here. So it's 132.9 times 2 plus oxygen, which is 16, which is 281.8. And that will go, oh boy, that'll go in the top spot. 281.8 equals, and then everything on top multiply everything on bottom. Let's go 1 mole. Everything on bottom divide. So 46.1 divided by 132.9 times 2 divided by 4 times 281.8 equals 48.8 roughly. Let's go ahead and label this. This is CS cesium. Now we need to go ahead and do oxygen because we don't know what the limiting reactant is. This is our formula to find percent yield. It's actual yield, which is the product. We know the product. The product is what we're given here in our original equation is 28.3. This is our product. These are our reactants. Now, in our reactants, there's always a limiting reactant and an excess. We don't know. It doesn't tell us in this problem which one is the limiting reactant and which one is the excess, which is why we have to now do oxygen. So let's go ahead and do oxygen now. Let's see here. Okay, oxygen, we're given 13.4. So 13.4 grams. Let's get our chart back out here. 13.4 grams. And we're going to mole. So we're going to divide. We're going to divide by the molar mass of oxygen, which is 32. Because in the periodic table, 16 times 2 is 32. So therefore, we now went from mass to mole given on the given side, on this side of it. Now we want to go from mole to mole. So what's our mole to mole ratio? Let's see here. Oxygen are given right here. See 13.4. We're on our given side. It's 1. Given goes on bottom. Given goes on bottom. Given always goes on bottom. There we go. So now we're going mole to mole. Mole to our unknown, which is 2. Okay, good. And then this will be the same because you're going from mole to mass. So you're going to multiply by CS2O, which is the same as this up here, 281.8. It's just the molar mass over 1 mole equals everything on top, 13.4 divided by 32 times 2 times 281.8. And that's going to give us 236, is that right? Yes, that is right. So obviously here, this is the excess. Okay, we don't care about the excess. No one cares about the excess because in our equation here, we only care about the limiting reactant here because that's the only thing that we're missing. So let's go ahead and take, this is the limiting reactant right here. So we're very happy here. Okay. Now what you want to do, take your limiting reactant. We don't need this anymore. Okay. Blank paper. We don't care about that. Let's go ahead and cover it up. Where is this? This is good. Good stuff right here. Percent yield equals actual yield over theoretical yield. Okay. So our actual yield is our product, which is given to us in the original problem, 28.3. So that's 28.3 over theoretical yield, limiting reactant, which is always a smaller one out of this one, which is why I crossed out 236. It's the excess, it's larger, nobody cares about it. Okay, well in our case, anyway. Theoretical, limiting reactant, 48.8 equals, go ahead and punch this in your calculator, 28.3 divided by 48.8. And then multiply it by 100 or move the decimal over, it doesn't matter. 57.9%. That is your final answer.